Hello, I'm Sven Bultreis, and for over a decade I have conducted research on the biology of aging as well as on advocacy for aging research. Over that time, I have probably heard every misconception about aging in existence. One of the most common misconceptions is that living longer will mean living in a longer period of time in a frail, decrepit state. People think that they will age, lose vitality, and get frail at the current rate, and hence start to get their first age-related illnesses around their 70th birthday, and be in need for assistance with those activities of daily living, such as getting dressed, cleaning, preparing food, and so on by the time that they reach 80 years of age. But instead of dying at say 85 and hence live in this decrepit state for 5 years, they believe that if they live to 100 years of age, that they will live in this state for 20 years, all the time getting even more frail and sick. Or, to state it even more extremely, people believe that if humans were to live to 150 years, that this would mean living in a bad health for 70 years. The bioethicist Francis Fukuyama has concluded that defeating aging would lead to a global nursing home. This is known as the Titonus error, after the Prince of Troy that, according to Greek mythology, fell in love with the goddess Eos. Eos asked her father Zeus to make her lover immortal, but forgot to ask for eternal youth as well. The consequence was that Titonus kept aging forever, ever getting more frail but never dying. Research shows that the Titonus error is a myth. This myth probably has its origin in two phenomena. First, we have evolved sophisticated defense mechanisms to deal with the horror of our own demise. And surprisingly enough, one mechanism is to deny the possibility that aging and death are not inevitable. A bit akin to how some captives eventually start to evolve positive feelings towards their captors. Second, as medical science has improved, we have increasingly become better at keeping critically ill people alive. However, treatments that slow down or reverse aging are very different from life support systems. Most people probably overestimate what such life support systems can achieve, particularly in people who are dying from old age. When we extend the lifespan of organisms by interventions such as genetic changes, we not only make them live longer, but we also keep them longer young. In technical terms, we say that both life and health span have been extended. Professor Cynthia Kenyon once described this beautifully and concisely when she said, "These will be like 500-year-old people playing tennis," to describe her mutant worms that live 6 times longer. During her Harvey lecture in 2006, Professor Kenyon recounted another story about these animals. When Nuno Arantes Oliveira, the graduate student doing this work, showed 244-day-old animals still moving around to other lab members and asked them to guess the age of the animals, they reckoned 5 days. Calorie restriction, the oldest and still the best research method to extend the lifespan, has been found to have a wide variety of health benefits, such as protection against Alzheimer's disease, type 2 diabetes, cancer, and cardiovascular disease. When we consider aging to be the accumulation of cellular and molecular damage, then it becomes instinctively clear that treatments that would revert this damage will not only extend lifespan, but will also extend health span. More so, such therapies would actually reverse aging and make one younger again. One example here comes from the recent studies with senolytics. Senolytics are treatments that kill senescent cells. When we grow older, more and more of these senescent cells accumulate in the body, and the molecules that they secrete stimulate inflammation and destroy the tissue structure. Genetic or pharmacological ablation of senescent cells has been shown to improve many aspects of health. Recently, the first human trial with senolytics has begun. In this trial, patients with osteoarthritis, a degenerative disease of the joints, will be injected in the joint with a senolytic drug. We are looking forward to the results of this trial. Finally, supercentenarians, those rare individuals who manage to live to over 110 years of age, are human examples of slowed aging. Many supercentenarians remain in exceptional health until very old ages. Jeanne Calment is the oldest verified person in human history. She died in 1997 at 122 years of age. She rode a bicycle until the age of 100. Another example comes from the Dutch lady Hendrike van Andel Schipper, who underwent memory tests at the age 112 and 113. And it was found that her performance was above average compared to the average 60 to 75-year-old. From all these examples and more, we can conclude that therapies that extend human lifespan by slowing down or reversing the aging process will not lead to Fukuyama's global nursing home, but rather to a healthy population. Thank you for watching.